Yesterday afternoon at 3:47 p.m. Eastern Time, solar astronomers at NOAA's Space Weather Prediction Center issued a quiet alert that most people missed. A sunspot region, numbered AR4341, has rotated into view from the sun's far side, and its magnetic configuration is what scientists call beta gamma delta. If you've been watching the sun as long as I have, you know that phrase means one thing. This region is loaded, primed, and capable of unleashing the kind of solar fury we haven't seen in months. Welcome back. For the past week, something extraordinary has been building on the sun's hidden hemisphere, the side we cannot see from Earth. Massive eruptions, violent explosions of plasma and radiation have been bursting from a region that remained invisible to us, tracked only by extreme ultraviolet cameras on NASA's GOES-19 satellite. Two major blasts occurred on January 13th and 14th, each one powerful enough to light up the solar atmosphere like a flashbulb. And now, that same region has rotated onto the Earth-facing disk. We can finally see it, and what we're seeing is deeply concerning. AR4341 isn't just another sunspot. When solar physicists describe a magnetic field configuration as beta gamma delta, they're telling you this region contains opposite magnetic polarities mixed together within a single sunspot structure, compressed, twisted, unstable. Think of it like a tightly wound spring, or better yet, a loaded gun. The energy is there, the trigger is sensitive. The question isn't if it will fire, the question is when and how powerful the blast will be. Over the last 48 hours, AR4341 has already produced multiple M-class flares, including an M1.6 on January 14th and an M2.2 just this morning at 10:19 UTC. That second flare triggered an R1 radio blackout over southern Africa, briefly disrupting high-frequency communications across the continent. Aviation, maritime navigation, emergency services all experienced signal degradation for several minutes. Not catastrophic, but a clear warning shot. Now here's what makes this genuinely fascinating. These M-class flares we're seeing now, they're just the warm-up. Beta gamma delta configurations are statistically the most flare-productive magnetic structures on the sun. Historical data from solar cycles 23 and 24 shows that roughly 80% of major X-class flares, the truly dangerous ones, originate from regions with this exact magnetic setup. And AR4341 isn't just beta gamma delta. Multiple observer reports confirm it also contains a gamma magnetic structure, an even rarer and more volatile configuration. Some of you watching this have lived through the great solar storms of the past, the Quebec blackout in 1989, the Halloween storms of 2003. You remember what X-class flares can do. In 2003, a series of powerful eruptions knocked out power grids, damaged satellites, forced airlines to reroute flights away from polar regions. That activity came from sunspot regions remarkably similar to what we're seeing now with AR4341. But let's talk about timing, because this matters more than you might think. We are currently in the declining phase of solar cycle 25. The solar maximum, the peak of activity, likely occurred back in October 2024. You might assume that means we're safe now, that the worst is behind us. History tells a different story. The most powerful solar flares don't always happen at solar maximum. They often occur during the declining phase, sometimes years after the peak. In solar cycle 23, 4 X10 class flares erupted in 2003, 2 years after the cycle's maximum. The famous Carrington Event of 1859, the strongest geomagnetic storm ever recorded, happened during a declining phase. So the fact that we're past the peak of cycle 25 offers no comfort. If anything, it means we should be watching more carefully. What do you think? Could AR4341 produce an X-class flare in the next 72 hours? Or will it quietly fade as it rotates across the solar disk? Write your prediction in the comments. NASA's Solar Dynamics Observatory is watching this region continuously now. Every 6 hours, new imagery shows the evolution of AR4341's magnetic field. The sunspot structure is growing. New spots have emerged just south of the main complex, adding more magnetic energy to an already unstable system. Solar physicists use sophisticated models to forecast flare probability, but the truth is, we cannot predict the exact moment of eruption. We can see the conditions, we can measure the magnetic stress, but the sun keeps its secrets until the very last second. Here's what we know for certain. If AR4341 produces a major X-class flare while facing Earth, and if that flare is accompanied by a coronal mass ejection, a billion-ton cloud of magnetized plasma, we could see geomagnetic storm conditions within 24 to 48 hours. That means auroras, potentially visible as far south as the northern United States. It also means potential disruptions to GPS systems, satellite operations, power grids, all the infrastructure our modern world depends on. This is why NOAA's new SWFOL-1 satellite, arriving at Lagrange Point 1 in just 2 days, matters so much. Better warnings mean better preparation. AR4341 is awake, it's active, and it's aimed at us. Thank you for watching, and share your flare predictions below. Until next time.